Hello, students. Today we are going to embark on an exciting journey into the fascinating world of force. Imagine a world where things don't move, where objects remain still, and there's no push or pull. Sounds a bit dull, doesn't it? Well, that's where force comes into play. Force is like a magical, invisible hand that makes things happen in our everyday lives. It is the push or pull that sets everything in motion, whether it's making a ball roll, swinging on a swing, or even opening a door. So let's dive into the realm of force and discover the incredible power that shapes the way our world moves and interacts. You'd be surprised at how closely force and motion go together. Suppose I asked you to move a heavy desk in the classroom. How would you move it? By getting on one side and start pushing it, or by grabbing the legs and pulling it? Either way, you would be using force. So what is a force? Force is a push or a pull that changes the motion of an object. Anytime you see something moving, you can be sure that a force created its motion. When two objects are physically touching each other, it is known as contact force. For example, pushing a book, pulling a toy, or kicking a ball. A contact is must in this case. The force that acts at a distance and doesn't require direct touch is known as non-contact force. The most common non-contact force is gravity, which pulls objects towards the earth. Imagine a tug of war where two teams are pulling with equal strength in opposite directions. In this scenario, the forces exerted by both teams are balanced. When forces are balanced, they cancel each other out, resulting in an object either remaining at rest or moving at a constant speed in a straight line. It's like a perfect equilibrium where opposing forces create harmony, preventing any change in the object's state of motion. Now let's consider a different tug of war where one team is pulling much harder than the other. In this case, the forces are unbalanced. Unbalanced forces lead to changes in an object's motion. If the forces are unbalanced in the direction of the stronger pull, the object will accelerate in that direction. Conversely, if the unbalanced forces act in the opposite direction, the object will decelerate or change its direction. A stationary object will not move until the force acting on it is balanced, whereas a stationary object moves when the force acting on it is unbalanced. Suppose the jeep that you are riding suddenly stops. What happens to you? Or suppose the jeep, which is initially at rest, suddenly moves forward. What will be your reaction? Your reaction can be explained by the concept of inertia. Inertia is a property of an object that describes how much it will resist to change the motion of the object. More the mass means more will be the inertia of the object. Newton's first law, or the law of inertia, states that an object at rest tends to stay at rest and an object in motion tends to stay in motion unless acted upon by an unbalanced force. Inertia is the tendency of objects to resist changes in their state of motion. Simply put, it's the reason why things keep doing what they are doing unless something else interferes. So if you have ever wondered why your toy car keeps rolling even after you stop pushing it, or why your pencil doesn't work or starts moving on its own, it is because of inertia. Unless acted upon by an unbalanced force, this golf ball would sit on the tee forever. The car is at rest and it is going to stay at rest until a force gives it a push. The tendency of an object to remain in its existing state is called inertia. This is why an object in stationary state remains in the same state and an object in motion remains in the state of motion in the absence of an external force. Have you ever wondered why a sharp knife cuts more easily than a blunt one? That's where the idea of pressure comes into play. Pressure is the force applied over a specific area. In simpler terms, it's like imagining the push you feel when you press on something. Understanding pressure helps us to explain why something can cut, squash, or pierce more effectively than others. Now let's think about knives. You might have noticed that a sharp knife can easily slice through things while a blunt knife struggles more. This difference is all about pressure. A sharp knife has a thin edge concentrating the force or push on a small area. When you use a sharp knife, the force is spread over a tiny surface, creating high pressure. This high pressure allows the knife to cut through things more efficiently, like slicing through butter. On the other hand, a blunt knife has a wider edge, spreading the force over a larger area. The force is now distributed over a broader surface, resulting in low pressure. Due to low pressure, a blunt knife might not cut as smoothly or easily as a sharp one. Due to natural adaptation, the bottom surface of camels' feet are broad. Hence, the camel's weight is exerted on a large area and the pressure on the sand is reduced. This is why camels' feet do not penetrate into the sand and it becomes easy to walk. Difference between force and pressure. The push and pull action resulting in acceleration of the object is known as force, whereas the force acting upon a certain area and acted upon something perpendicular to its surface is known as pressure. The SI unit of force is Newton, represented by capital N. The SI unit of pressure is Pascal, represented by PA. The instrument used to measure force is known as dynamometer, whereas the instrument used to measure pressure is called manometer. Force is a vector quantity, which means it has direction as well as magnitude. Pressure is a scalar quantity, which means it does not have direction but only magnitude. Force can be acted upon the face, edges, sides or vertices of the object. Pressure only acts on the surface or face of the object. In summary, while force represents a push or pull in a specific direction, pressure focuses on the force distributed over a given area. Understanding these concepts help us explain various phenomena in the physical world.